everyone, thank you so much for clicking onto the video. Here are today's learning objectives. So the first is to know what is meant by the term oxidation number, and then to be able to calculate the oxidation number of elements in compounds and ions. Then we're going to look at understanding oxidation and reduction in terms of electron transfer and changes in oxidation number, and then in terms of electron loss or electron gain. We're then going to look at how oxidizing agents gain electrons and reducing agents lose electrons, and then understand that disproportionation reaction involves an element in a single species being simultaneously oxidized and reduced. And then we're going to look at how the oxidation number is a useful concept in terms of the classification of reactions as redox and as disproportionation. Then we're going to look at indicating the oxidation number of an element in a compound or ion using a Roman numeral, and then finally be able to write formulae given oxidation numbers. Now we're going to look at how to work out oxidation states. So we have a few general rules. The first is that for simple ions, it's normally the charge on the ion. And so, for example, if we have copper 2+, then the oxidation state for copper in this ion is +2. The oxidation state for copper is +2. And the second rule is that in elements, the oxidation state is equal to 0. So for example, if we look at chlorine, so we have Cl2, the oxidation state that we have for chlorine is 0 because chlorine is an element. And the third rule is that the total of all oxidation states must equal the overall charge of the species. And then we have that in molecules or complex ions, the more electronegative element is assumed to be the negative one. And finally, hydrogen is nearly always +1, and oxygen is nearly always -2. So, for example, we're going to work out the oxidation states of all of these elements in each of these compounds. So firstly, we have NO3-, and this is the nitrate ion. So we have NO3, and then the overall charge is minus. So because oxygen is much more electronegative compared to nitrogen, basically it has a stronger ability to attract electrons in a covalent bond, the oxygen will be the negative ion. So this oxygen is nearly always -2, that's the fifth rule that we have. And so we give oxygen an oxidation number of 2, -2. And because we have 3 of them, that means we have 3 of these -2s. And because the overall charge is -1, we need to make the overall charge of this species equal to -1. So if I call the oxidation number of nitrogen X, we have X and then -6, and then this has to equal -1. And so rearranging this, we get X equals -1 plus 6, which is +5. And so we have that the oxidation number of nitrogen is +5, and then the oxidation number of oxygen is -2. So we have nitrogen is +5 and oxygen is -2. And to work out which element is more electronegative, we have that electronegativity increases across a period and increases up a group. So fluorine is the most electronegative element that we have. And then looking at potassium chloride, so we have KCl, and this time the most electronegative element is the chlorine. So we give this a charge of -1 because chloride ions are always -1. And this actually works out because potassium is in group 1, and so it forms +1 ion. And so we have that the oxidation number of potassium is +1, and then for chlorine we have -1. Dichlorine trioxide, which has the formula Cl2O3. And so if I have Cl2 and then O3, and these two are actually very similar in electronegativity, but oxygen is nearly always given -2, and so we give -2 to oxygen. And then we have 3 of them, so again we have another 2 of these -2. And now we have to look at the overall charge of the compound. So the overall charge is 0. And so again, if we put X, but this time because we have 2 of these chlorines, we need 2X. and then we have -6 is equal to 0 because it's neutral. And so rearranging this, we have 2x is equal to +6, and so x is equal to +3. And so now we know that the oxidation number of chlorine is +3, and for oxygen is -2. And then for hydrogen peroxide, this is a bit of an anomaly because we have both hydrogen and oxygen, and we have the rule that hydrogen is nearly always +1 and oxygen is nearly always -2. And so it can be difficult to see which one we actually give the +1 to and the -2. But actually we give oxygen -2 instead of giving hydrogen a +1. So this is just one of the ones where you need to remember what happens. So if oxygen has a -2 and it has 2 of them, so then we'll have 2x minus 4 is equal to 0 because it's a neutral compound. And so rearranging this, we have 2x is equal to +4, so x is equal to +2. So as you can see, the hydrogen will have an oxidation number of +2 instead of +1, which we normally expect. And the oxygen will have the -2. And then finally for sodium hydride, again, this is an anomaly. And this is where we actually have hydrogen having a negative oxidation number. So we actually give the sodium a +1, and then the hydrogen will get a -1. So we have the oxidation number of sodium is +1, and for hydrogen we have -1. Now we're going to look at some redox definitions. So the definition for oxidation is the loss of electrons, or we can also describe it as the gain in oxidation number. And reduction is the opposite of this. So it's either the gain of electrons or the decrease in oxidation number. And so an oxidizing agent is something that oxidizes something else. And so it's a reagent which gains electrons. And a reducing agent is the opposite. So it's a reagent which loses electrons. So for example, here we have a redox equation. This is iron oxide reacting with carbon monoxide to form iron and carbon dioxide. And so we can work out the oxidizing agent and the reducing agent and also what's being oxidized or reduced. So the first step we have to do is work out all the oxidation numbers. So firstly, for iron oxide, we have Fe2O3. And again, we need to remember the rule that oxygen normally gets -2. So if we give oxygen -2 and we have 3 of them, then what we have is 2x minus 6 is equal to 0 because it's a neutral compound. And so we have that x is equal to +3. So here for the iron, we have +3, and for the oxygen, we have -2. And then here for the carbon, we will have +2 because the oxygen gets -2. And then here, because iron's an element, we have 0. And then for carbon dioxide, we have carbon. So again, if we look at this, we have CO2, and oxygen normally gets -2, so we give that -2, and there's 2 of them. So we get x minus 4 is equal to 0, so x equals +4. So the oxidation number of carbon would be +4, and oxygen would be -2. So now we can have a look at which elements have lost electrons or gained electrons. So we do this by looking at the oxidation number. So if there's a gain in oxidation number, then it's been oxidized. So for example, if we look at iron first, iron is +3 in this iron oxide. But after the reaction occurs, this iron then has an oxidation number of 0. And so this means that going from this iron oxide to iron, reduction. Because we have gained electrons and the oxidation number has gone down. However, when we look at the carbon, so we have in carbon monoxide, we have the oxidation number of carbon is +2. And then after the reaction has occurred, the carbon dioxide, which has been formed, the carbon has an oxidation number of +4. And so the oxidation number has increased. And so this time what we have from this carbon monoxide to this carbon dioxide, we've gone through oxidation. And so we can find the oxidizing agents and the reducing agents because it's just, so the oxidizing agent would be this Fe2O3 because it's reduced itself. So what it's done is it's taken away electrons from the carbon monoxide to oxidize it, and it's going to be reduced itself. And so that's why it's gone through reduction. And then the reducing agent would be this 3CO because it's oxidized itself. So this is the reducing agent. So this is given electrons to the iron oxide to become oxidized. And we can actually apply these definitions for oxidation and reduction to form equations. So what we could have zinc. So zinc exists as an element, and then what happens is that we can take away 2 electrons to form a Zn2 plus ion. So we would form Zn2 plus and 2 electrons. So this is an example of oxidation. And then for an example of reduction, we could have chlorine. So chlorine exists as a diatomic molecule. So we have Cl2. And so we need to add 2 electrons to form 2 of these chloride ions. And so this is our example of a reduction reaction. Now we're going to look at a specific type of redox reaction, which is a disproportionation reaction. So they are reactions where the same element is both reduced and oxidized during the reaction. And you'll need to know this definition. And oxidation numbers are very useful in classifying reactions as redox reactions or disproportionation reactions. So in this example we're going to look at, and we're going to discuss whether it's a redox or a disproportionation reaction. So we've got 2 of this copper 1 chloride, and then we're going to form copper 2 chloride and also a copper. So we have copper 1 chloride, so the oxidation number of chlorine will be giving -1, and then copper we would give +1, and this is why we call it copper 1 chloride, and we'll go into this a bit later. And then for copper chloride with the 2 chlorines, we would have that each of the chlorines would be -1, and so the copper would be +2. And then for copper, this would be 0 because copper is just an element. And so now we can have a look at the oxidation numbers and see what's happened. So we started off with the copper being +1. And then in the copper chloride which is formed, we have copper as +2. And then the copper which has been formed, the oxidation number of copper is 0. And so we can see that here we have gained in oxidation number. And so this is where oxidation has occurred because we have lost electrons. But then when we look at from copper chloride to copper, it's been reduced. So this is reduction because the oxidation number has gone down from +1 to 0. And so we can see that the copper in copper chloride has been both oxidized and reduced during the same reaction. And so this is a disproportionation reaction. So we have that copper in CuCl has been oxidized and reduced simultaneously, and so therefore we have a disproportionation reaction. Now we're going to look at writing formulae using oxidation numbers. So sometimes different compounds will have the same name, but the elements in each of these different compounds will have a different oxidation state. So for example, we could have iron 2 oxide and iron 3 oxide. So they have the same name, but in iron 2 oxide, the iron has an oxidation number of +2, whereas the iron in iron oxide, in iron 3 oxide, would have an oxidation number of +3. And we use Roman numerals to indicate the oxidation state of a particular element in a compound. And so the Roman numerals we have are 1, and then we have 2, 3, 4, 5, 6, and then we have 7, and then 8. So you need to memorize all of these different Roman numerals. So the example we're going to look at is firstly a sulfate. So what we do is we just work out the oxidation numbers as usual. So we have SO4, and this has a charge of 2-. So again, we give oxygen a -2, and because we have 4 of them, we have -8. So we have X -8, and this has to equal -2 because the overall charge of the ion is -2. And so we have that X is equal to -2 plus 8, which is +6. And so this sulfate is a sulfate. And then we use the Roman numeral for 6, which is a V and then an I. So this is a sulfate 6 ion. And then looking at a nitrate, so we have NO3-. So again, what we do is work out the oxidation numbers. So we have -2 for the oxygens, and we have 3 of them. So we have X -6 is equal to -1, which is the overall charge. And so we have that X is equal to -1 plus 6, which is +5. And so this nitrate ion is a nitrate. And then we need the Roman numeral for 5. So we have a V, and this is a nitrate 5 ion. We might also be asked to suggest formulae given oxidation numbers, so the other way around. So they could ask us, suggest a formula for the chlorate 3 ion. So what we need to do first is we need to know what a chlorate is. So a chlorate is chlorine and also oxygen. And so we know, because this is the Roman numeral for 3, that the oxidation number of this chlorine in this chlorate ion is equal to +3. And we know this ion has to be negative because it only contains chlorine and oxygen. And so we just need to add enough oxygen to make this ion negative. So first let's try Cl and then O. So what we would have here would be the chlorine would be a +3, and then the oxygen would be a -2. So then we'd have an overall charge of 3 - 2, which is +1 or 1+. And then we can try ClO2. So again, we'd have +3, but this time we would have 2 of these -2s. So it'd be +3 - 4, which is equal to 1-. And so this must be our formula for this chlorate ion. So we have that formula for chlorate 3 ion, ClO2-. Now we're going to look at a question. So identify the oxidizing agent, reducing agent, and the species which have undergone oxidation and reduction in this reaction. So we can actually work this out by looking at the oxidation state. So the oxidation state of the chlorine in Cl2 is 0, because for elements it's always 0. So we have chlorine, which is 0. And then Br- is a simple ion, so its oxidation state is -1. And then for Cl-, the same thing, so Cl will be -1. And then for Br2, it'll also be 0. And so oxidation means losing electrons. So if you remember oil rig, that should help you remember about oxidation and reduction. So this stands for oxidation is losing, reduction is gaining. And so oxidation means losing electrons, but it means that the oxidation number is going up. And so that means that this bromide ion is getting oxidated. So this is where oxidation occurs. And that means that the chlorine is getting reduced. So that's reduction. And so now we can identify our 4 things. So the oxidizing agent is the electron acceptor, because it oxidizes the thing that is losing electrons. So the oxidizing agent itself is accepting electrons. And so because the bromide ion is getting oxidized, that means that the oxidizing agent is this chlorine 2. So the chlorine molecule is the oxidizing agent. And that means that the reducing agent is this Br-, because it is giving away the electrons to the chlorine. And then the species which has undergone oxidation is the bromide ion, and the species which has undergone reduction is the chlorine molecule.